Hey guys, this is the homework and notes for 9.1. So let's do it. Our assignment says, please complete 18 to 21, 24 to 26, and 28 to 30. So let's do it. All right, it says, use this figure for the next group of questions. Is ABC a scaling? That means all different, right? Isosceles, two the same, two sides the same length, and two angles the same. And then this is three sides the same length. Where's our right triangle? So that means we either confirm a squared plus b squared is c squared, or we confirm that we have slopes that are perpendicular, which are opposite reciprocals. Well, let's take a look. Triangle ABC, okay. Oh, it looks isosceles. If I look at this triangle here, it looks like I went up 1 over 3. So that's 1 squared plus 3 squared. Right? And then this one, it looks like 1 and 3 make that one. So that's also 1 squared plus 3 squared. So those would be equal. So the other one is a lot longer. So I'm going to say this is isosceles. Because two sides equal. All right, what is it a right triangle? Okay, so that means we get it. So the only angle that looks, so angle B looks like it. So let's check that. When I think about this slope, the slope of AB is, I went up 1 over 3. The slope of BC is, I went down 3 over 1. So I have to say, yes, it is a right triangle because these are opposite reciprocals. Nice work. Let's take a look at 19. It says, is ADC scaling isosceles equilateral? So same question. So let's analyze 19. I'm just going to kind of erase that. And look at ADC. So that is this triangle. Interesting. Okay. Now, just like we did before, let's look at these lengths here. So this length is 5. You can just kind of count that, 5. This length is, looks like I went 4 and 2. So that would be 4 squared, 2 squared, and take the square root. This side, I went 4 and 3, so that's different. 4 squared and 3 squared. So analyzing each of these side lengths, I have one side is 5, one side is the square root of 4 squared plus 2 squared, and another is the length 4 squared plus 3 squared. So those are all actually looking different. Let's dig a little deeper. All right, so that would be 16 plus 4, so that's the square root of 20. That'd be 16 plus 9, so that's the square root of 25. Okay, so this is 5, and that's 5. And this is a decimal, like 4 point something. All right, so let's just grab a calculator. The square root of 20 is 4.4. Okay, so this is definitely, yes, it is isosceles because two sides equal. Or congruent, right? And is it a right triangle? So let's dig into that a little bit. Yeah, none of those look like they're a right angle. You can verify that with slope, but they're They're definitely, if it's graphed precisely and it's not even close to 90, it's not going to be 90. Okay, now let's look at, I think the next question is to analyze this next one. So it says, oh, maybe not. I spoke too soon. Okay, so question number 20 says, what type of parallelogram is ACED? So ACED, what type of parallelogram? So remember we had a chart, right, of parallelogram, and there was different kind of parallelograms, right? We had like our rhombus, and then under a rhombus was our square, and then we had, I don't know, we haven't looked at that little flow chart in a while. Okay, so maybe just a regular, a rectangle, right? You could have like a rectangle, and yeah. So those are our types of parallelograms. So let's dive in. We're like, is it a rectangle? Well, no, it's not a rectangle. It's definitely not a square. But so is it a rhombus? So to verify that, the definition of a rhombus, so if we want to try to see if it's a rhombus, the definition of that is all sides equal. Or you could also think of as congruent. So let's analyze that. Okay, this one is 5 and this one's 5. And this one is, didn't we already do this? It's 2 squared plus 4 squared, which we said was 4 plus 16, which is the square root of 20, which is 4.4 something. And so this is definitely not a rhombus. Okay, so it's not a rhombus, a square, or a rectangle. So it's just a plain old parallelogram. All right, 21. What type of quadrilateral is ABCD? So kind of erasing this to get back to my figure. What kind of quadrilateral is A, B, C, D? So it kind of looks like kind of a jacked up. Could it be a kite? Yeah, it kind of looks like a kite if I turn my head. Okay, so let's investigate if it's a kite. And so that's consecutive, sides, congruent. So I would have to verify that these two are equal and these two are equal in length. So let's do just that. The length of AB is, we already said this, 1 squared plus 3 squared, and take the square root. The length of BC is, the same thing. So those are equal. So that's one set of consecutive sides. Now let's analyze AD and CD. So that's, we can count 1, 2, 3, 4, 5. So AD is just plain old 5. And CD is 4 and 3. Yeah, 4 squared plus 3 squared. So, and take the square root. I think we already verified this, right? It is the square root of 25, which is 5. So you're going to have to say, yes, this is a kite. Why? Because it has consecutive sides congruent by definition. Now, 24. The next set are like example 3 in our notes. So let's take a look. It says 3 vertices of a quadrilateral are these 3 coordinates. Okay. Suppose QRS is a parallelogram. What are the coordinates of the vertex? What are the parallelograms? Okay, so we definitely need some graph paper. So let's dig a little bit deeper here. I'm going to take a picture of this. Open a new page. Yeah, and I'm going to go to the internet. Again, I show you this in case you're joining us from home. If you're in class, you probably, just got some graph paper from me. Okay, so I'm just going to put graph paper. All right. And we'll insert that picture. Got some graph paper here. And I'm going to insert the question they'd ask us. Okay, so question 24 states, graph these. Okay, so I'll make this my coordinate plane. And this thirst point is -2, +3. So that's P. The next coordinate is +2, +4. That's Q. And then 1, 0. So that's R. So here's our shape that we've been asked to investigate, PQR. There are 3 vertices of a 4-sided shape. So that means we're missing one. We're missing one coordinate. So for instance, if this was an extra coordinate, then this would turn into a 4-sided shape. If this was the coordinate of the 4th side, then again, this would turn into the 4-sided shape. So I think that's what they're asking. All right, so what are the coordinates of vertex S? And it's supposed to be a parallelogram. So there's a couple of places I could put this. What are the coordinates, plural, or what type of parallelogram? So if we investigate here, this has a slope of, it went down, right? Down 2/3. And so that means this would need to go down 2/3. So I can so it looks like S would need to be here. So the slope of SQ needs to be down 2/3. And then again, it's a parallelogram. So this slope, so the slope of QR is up 3/1, which means the slope of PS would have to be up 3/1, which it is. Okay, so it's a parallelogram because the definition of a parallelogram is opposite sides are parallel. What does parallel mean? Well, parallel means parallel is same slope. So notice we did verify those have same slope. What type of parallelogram? It's not looking, it just looks like a regular old generic parallelogram. Doesn't look like a rectangle or a rhombus. Now 25 says, suppose PSR is a parallelogram. What are the coordinates of vertex S? What type of a parallelogram is it? Okay, so it looks like it's asking me the same. So essentially, maybe I'm missing something. Maybe I'm just tired. I did have the AP weekend. So I'm going to graph it again. So R is 1, 0. So that's my R. P is -2, +3. That's P. And then Q is 2, 4. So I don't know if you're noticing, but like, see how I could have gone over this side, like down 2/3 and put a dot over there. So I think I could have done that, right? And adding that dot over there would have created a parallelogram. So continuing like it did last time, we already defined it here, right? But it looks like this coordinate, 5, what is that? 1, 2, 3, 4, 5, 1, 2, 5, 2. So the coordinate, oh, I forgot to write here. So the coordinate here we made for S was -1, and then +1, 2, 3, 4, 5, 6. So 6. Now what would be another coordinate we could make for S? It looks like I made it at +5, 2 for S. And it's still just a regular parallelogram. I'm not getting any right angles, and those do not look like the same length. I could prove it mathematically, so because the length, the distance of PR is equal to the square root of 1 squared plus 4 squared, And the distance of QS is the square root of 3 squared plus 2 squared. So I don't think that's the same number. This is the square root of 17, and this is the square of 13. Yeah, so those are different lengths. So it's definitely not a rectangle or a rhombus. Okay, nice. So what else we got here? 26, it says, use appropriate tools. The architect overlays a coordinate grid where her plans for attaching a greenhouse to the side of a house. She wants to locate, okay, so here's her house. I think all this kind of shaded in. And she wants to locate point D so that A, B, C, D is a trapezoid. So here's A, B, C, and she wants a trapezoid. What are the coordinates for D? So a trapezoid is when the sides are parallel. So either you can maybe put D here, and then that would make this parallel to that, and there you go. Your greenhouse is a trapezoid. I'm going to undo that. You could also maybe put it anywhere along in here, and that would be a trapezoid, right? So anywhere where, so any number where the y value is 8 would create a trapezoid. And then notice, if I erase this here, I would create a trapezoid as long as I stayed parallel. So this slope, or if I stayed parallel, so notice if I kept that parallel, that would be an isosceles. So how would I stay parallel? With the slope of line OC is rise 8 over 2. So that'd be a slope of 4. So as long as I maintain a slope of 4. So let's see. That would mean it would have to go through a point. So I could go over 1 up 4. That would be a trapezoid. So that would be the point 5, 4. Nice. Okay, then the next group, or the last group, 26, 27, 28. Let's take a look. Or 28, 29, 30. The map shows the regions that Anna and Richard have explored. Each claims to have explored the greater area. Who is correct? So we have to compare these areas. Okay, so Anna's area is, it looks like Anna's got a right triangle. So let's look at these coordinates. This is coordinate 410. This is coordinate 86. Okay, so what's this distance? Well, it looks like I went up 4 over 4. So this is the square root of 4 squared plus 4 squared. And this is the same thing, 4 squared and 4 squared. So that distance would be 4 squared plus 4 squared. And how do we know that's a right angle? Well, we have to compare these distances. So I'm just going to call this A and B. So what's the slope of AB? It looks like it's 4 over 4 going uphill. And what's the slope BC? It looks like I'm going down 4 over 4. So these would be opposite reciprocals. So yes, that's a right angle, right, and that would mean it's a right triangle. Angle B is a right angle. So with that, if we know our formula for the area of a triangle is 1/2 base times altitude. So that's actually an altitude. So we can say it's 1/2 times the base, which is, what do we got there? 16 plus 16. So that's the square root of 32. And this one would also be the square root of 32. So I have 1/2. The base is the square root of 32. And the height is the square root of 32. So what, the square square root of 2 times the square root of 2 is just the plain old 32. So my area is 64. So 64 is the area of my first triangle. Now we have to compare it to Richard. Okay. Well, there's a couple ways to do this, but one way is just Richard would be a right triangle, but they cut off that little sliver right here. This little sliver. So let's just figure out Richard's triangle would have a base of 9, it looks like, the big one, and a height of 4. So it would be the same formula. Base of 9 and a height of 4. So that would give me 36 divided by 2, 18. All right. Hold on. What did I do? Did anybody catch? I'm like, wait a minute. These areas are up. Half of 32 would give me 16. All right. Phew. Thought I was going crazy there for a minute. I'm sure some of you caught that. Okay, so now I'm trying to do this orange one. Well, the orange one, before I cut it off, is 18, but now I got to cut off this sliver. So what is the area of that sliver? So it's 18 minus the sliver. Okay, so what's the sliver? We need to think it's a 1/2. The base looks like it's 1, and the height is 4. So that would be 4/2, which is equal to 2. So when I plug that in here, 18 minus 2 is 16. So they thought somebody was greater. Neither is correct. Both thought the other one was greater. Neither is correct. Both are equal areas. All right, 2 more. An equilateral has a vertice of these 4. What kind of quad is it? Okay, so let's get out our graph paper. So if that's my origin, I have -1, +4, and I'll call that A. 1, -2, I'll call that B. 4, -1, I'll call that C. And 2, 5, I'll call that D. What kind of triangle is this? So let's investigate. It looks like a rectangle. But let's confirm. So rectangles have 4 90s. So let's do that. So we need our slopes to be opposite reciprocals. So the slope of AB is, I went up 1 over 3. The slope of BC, I went up 1 over 3. So right now we got they're parallel, but we're not really trying to find if they're parallel. We're trying to find if these are opposite reciprocals. So the slope of D, this one, DC, is, it looks like I fell 1, 2, 3, 4, 5, 6, and I went over 2. Fell 6 over 2. So what do you know? Those really are opposite reciprocals. Let's just confirm with this one. 1, 2, 3, 4, 5, 6, 1, 2. Yep, the slope of AB is -3 over 1. So yes, these are, this is a rectangle because all angles are 90 and all angles are 90 because all the slopes of all the lines are opposite reciprocals. Cool. Okay, last one. What is the most precise classification? So getting our graph paper. We're not going to do that problem, so we can just kind of blow it up. So I need, let's just say I make this my origin. So I have 1, -2, that'll be J. 7, +1, that'll be K. 8, -1, that'll be L. 2, -4, that'll be M. Kind of looks like a rectangle, so that would be probably the most specific name. So we have to verify these slopes. So the slope of JM, it's definitely not a rhombus, all equal sides. It could maybe be a trapezoid. It's definitely not a kite, that's consecutive. So let's verify that it's a rectangle. So that would be the slope of that looks like it went down 2/1. The slope of ML looks like I went up 3/6. So up 3/6. Looky there, opposite reciprocals. Now let's verify the other slopes. So the slope of JK looks like I went up 3/6 again. So 6 is, yep, those are also opposite reciprocals. Last one, the slope of KL, looks like I went down 2/1. So fall 2/1. And what do you know? Again, these are opposite reciprocals. So our answer is a rectangle. Thanks for joining us, guys. Happy graphing.